So we have Ricky NG Adam, who is going to talk to us about a hardware startup adventure in China, and I'm going to let him tell his story.
Yep. So, as I said, my name is Ricky. This is actually my wife is in the audience. She's also been part of the project. And the project is called Philo. And if you've read the abstract, I said that I was going to talk about ARM and FPGA, and talk also about a little bit about China, doing business in China, doing a startup in China. So why should you care about this talk? So I'm going to, if you've never built an ARM platform, then this could be interesting. Some hints on how to proceed, and new ideas on embedded system. So I think we have some interesting concept that we brought on the platform, and also learning a little bit about how to actually get the platform manufactured in China. So people ask me why, so I'm French-Canadian, I'm originally from Montreal, and people ask me why China? Why are you in China? So I think it's because China is moving, it's booming, it's lots of things happening in China. And obviously, with such a large population, both in the country and in the city of Shanghai, like, as you know, there's lots of interesting people that you can meet and do project with. So Shanghai is astonishing as a city. So if you've never visited it, you should check it out. So they just got beaten by Beijing in terms of subway length, but yes. And it started, but they started building it in '95. Okay, in '95 they had no subway system, and now they have one of the second biggest, and probably they're going to go get back first soon in the world. It's completely astonishing, and world busiest port, lots of container traffic. So people often talk about Shenzhen in terms of manufacturing, but actually Shanghai has a lot of factories in the surrounding Jiangsu, and they ship a lot of container traffic. So really good. Now there's some downsides to being in China. So typically, there's two big things that annoys expats living in China. So that's air quality, which has been particularly bad in the last 2 months. And what I found really interesting is to find the equivalent air quality index standard for Australia is 25. And like there's these pages saying, oh, if it increases by 10%, it's going to increase death and it's going to be terrible. But actually, you know, we're living in cities that have much terrible air quality. So something that they'll need to fix soon. The second part that really annoying to expat is censorship. So we don't get the internet that other people get. So we live in a kind of intranet. And I mean, some of the things are expected, social networks. But other things such as Blogspot and GitHub, which was blocked for a day, are really, really annoying for developers, right? So you try, as a software engineer, myself, it makes it really difficult to do research, because then you have to get the VPN on, the VPN doesn't work out the time, it's slower, so it's like very, very annoying. But that's the reality of it. Now there's upside. One of the biggest upside, Taobao. Taobao is this huge market that has many different companies selling on. So it's kind of Amazon, but it's actually individual stores that are selling parts. So you can find anything on Taobao. So typically when people ask us, say, could you find this? You say, yes, it's on Taobao. We don't even check. It's there, guaranteed. So that's just an example of what the big benefit of doing business in China is, from a hardware building perspective, is that the supply chain, right? So we can get all the parts and all the components quickly and have them delivered mostly next day. And that's been like a big part of what Minlin has done for the hardware startup, is to source these components, right? Because you need to go online and talk to the merchant and get them delivered and find the right parts and make sure that they get on time and then they get them tested. But it's a lot easier to do in China. So, so I was in Shanghai, and I had a job, and then I quit my job to do hackerspace, because I found that really interesting, being in the hardware side of things. and you know, lots of crazy ideas and meeting lots of very interesting people. And one of those persons, Xiu Li, who's probably one of the best hardware designer in the world, came to the space, and we started talking about projects, and we decided, let's do a hardware startup. So, you know, very easy recipe, just 3 dots here and then profit, right? No problem. So inspiration. So for people who don't know the Arduino platform, it has made interfacing with sensors and control actuator very easy. It has made it so possible for people to build a physical device at a very low price. It has a very easy to use software environment, and that's a little bit where we started. So hackerspaces use a lot of these Arduino platform in various projects. So we decided, let's see if we can take that to the next stage, which is this ARM and FPGA platform. I've got a sample here, you know, that adds some of the functionality that's been missing to turn some of those hardware control device into network control device. So we're combining ARM and FPGA together, and what we want to achieve is to have the CPU with the ARM Linux operating system taking care of the high-level logic, the networking, which is all stuff that's very asynchronous, right? And then give to the FPGA the task of doing PWM or doing PIDs or tasks that are really real-time. So everything open source, open hardware.
What's PID in that context?
It's a proportional integral derivative, so it's typically, okay.
Stuff.
Okay, yeah, it's for the control system, so you can...
When you say PID, my mind goes to process IDs.
Ah, sorry, yeah, it led, yeah, Linux conference, right? And I've tried to put smaller, like I want to use JavaScript everywhere, right? So why? Because a lot of people that are interested by that platform, by internet connected device, might have a background as a web developer. So they're looking for something that they know to do the front end, the server side, and control the hardware. So we could do robotics, 3D printers, maybe some signal processing, software SDR, and internet connected device. And some of the spec that I guess it's not, so it's a very nice piece of hardware, I can tell you. Maybe we can talk more about that. You can look at the spec online. But basically it's the ARM CPU is a system on a chip. So it has lots of built-in functionality with 128 meg of RAM. And then there's the FPGA itself, which has about, it's Altera Cyclone 4. It has about 15,000 logic units. So it's a mid-size FPGA. And we've selected these components to do a good balance between power consumption and functionality. So different subsystems, so I think I've touched on that. And this is the kind of system diagram. So one of the big benefits here is that lots of the projects that we see use a PC computer and have an Arduino computer and a serial connection between both. But that kind of limits the bandwidth that you have. So in our system, because the Cyclone 4 FPGA appears as a memory bus device, then we get a lot more potential traffic and I/O between the Linux operating system and the different I/O device. And because it's a reprogrammable piece of hardware, we can put any kind of virtual electronic design that lets us interface and do logic processing on the input outputs. So there's different peripheral that we're working on, different projects that we could control. There's like generic shield system to expand the functionality. In this case, this is for Seed Studio. They have a Grove standard interface. So they connect sensors to standardized connectors. And we've built a shield that has analog ADC, analog to digital converter, and also digital connections. So that people could just use that shield and then plug in the sensors and actuators directly. Okay, so software-wise, so I'm going to go through this pretty quickly because it's the high level, what we want to offer to the user. But basically, the concept is we want to make this an internet-connected device. So everything in the browser, right? So including the management of the system and also the development and running like the UI. So lots of the stuff is going to be running in your browser and be served by the little device. So we're trying to take advantage of the fact that Linux has a very good networking stack and browsers are very powerful, so we can take advantage of that. So you can log into it with GitHub. So security-wise, it's pretty open system because we're assuming that this is really just you have the hardware next to you, so you have full control of it. But we use the integration with GitHub to ensure like source controls and stuff like that. So you can do different tasks, and the idea is, so this is just there's nothing behind this, but the idea is to create all the equivalent functionality that you would get in your desktop environment to control the system. And you can add application, so you can check out from your available repositories. You can have them locally, and you can run them. So it's not the nicest. I have a much nicer example application now, but you can get it. And this is a Cloud9 web development environment. So in your browser and your laptop, you connect to the device, and you start up the web development environment, and you can start editing programs and that serve both as the user interface, as the server side, but also as the control part for the hardware. So, okay, so once we've, so this is supposed to be YouTube. Okay. A little bit of a drink. So the most fun part of this project was actually spending these 2 weeks at the factory, getting a small batch of the hardware assembled. And it's very interesting. So we went there, and the factory is, we were set up in a room that's unheated, so it's like really cold for 2 weeks in December. And they bring us, so they produced it and then brought us the boards, and we started testing them. So the great thing is the first board we got was like totally working fine, great. And so we're super happy, wow, this is going great. We test the second board, not working. Third board, it blew up like our test processing card. So we're like, what is going on? And so what we found out is that it's really, really important. So you can't, the total yield originally was 10%. So 10% of our boards were actually working boards. All the rest of them had issues, from like bad soldering or components that were rotated, or a whole bunch of issues that we had to solve. Basically, we had to test them, isolate the issue, and then get them tested. So luckily we had the help, because I'm a software engineer. My wife is a software engineer. We have no idea, right, of most of this stuff, and we had help from the company that's our partner, Meteoroid, in Shanghai, to do the testing. But so this video shows a little bit the actual factory, so assembling with all the components. And what is interesting is, so once it's done, so most of the assembly is done by machines, but the problem is, because some of the components are so few, they do a hand assembly of it, and that's where all the problems are actually. So because of it's either components that are failing when you get them, or it's because they've assembled by hand. So key here, what's interesting, the conclusion is, if you can scale your production up, if you can do a lot more units, you can actually get less problems, because the machine is much more reliable than the little factory girls that, they're very good at soldering, but they don't necessarily know how the component's supposed to fit. So, and there's a whole process of X-ray of the components. So you just stand next to the machine, and it's like X-ray on, and you stand there for 15 minutes looking at the computer. It's really interesting. Okay, so that's the video. Hopefully I can move to the, okay. So what's the software stack? So this is where we're getting into Linux conference content. I'm going to look at the time. Okay, 27. So this is the what we had to build, basically. So because when you get the hardware, it's kind of useless. It's just a piece of hardware. What you need to put on is the software to get it running and get all the functionality out of it. And that's what we've been working for the last few months. So the first part is the bootloader. So this is, you'll notice, it's not U-boot, it's M-boot. So it's our own bootloader. Then there's the FPGA image, which is written in Verilog. Linux kernel, of course. Debian Wheezy, which has been great. Like, they have a full set of packages for our platform, the RML packages. So it's really easy, actually, to assemble an operating system for a new platform like this. And then we've built like a driver to expose the functionality to talk to the FPGA. And so then the rest of it is just the application side of it, right? We needed to write the JavaScript engine and management console and the browser IDE, which we're actually reusing a lot of the components that are already out there. So yeah, this is once it's booted. So it looks like this. So how do we get there? So this is the boot process. So it's a lot of, like, the development is a lot of looking at and reading the data sheet. So obviously this system on a chip has a very extensive data sheet, and I think that's one of the difference between the world of electronics and software. Is electronics is much better defined interface and specification. So it's really, really important to read through and understand the full data sheet. And so the software is built on top of that process documented in the data sheet of the system on chip. And the key part, this is where it gets fun. Once you get there and you do the boot Linux, you set the in-memory parameter, you load the kernel up, and then you pass a control to the kernel. And this is where it's happening. So to do that, we've forked the Linux source, and luckily lots of the work was done for us because Atmel has development kits that they use. So ours is just slightly different from the development kits. So we could use a lot of what the functionality was. What we needed to do is to add some of the FPGA memory device address into it. So we created this file board, Tabby. Tabby is the code name for the project. And we also, so this is what it looks like. Also, this is the memory address, the remap, devices. So this is changes that are specific when you select Lofilo Tabby in the menu config. You get these particular settings. So there's just different pins that are being used to achieve some of the functionality that they're doing. And we have a configuration file, of course, and you'll see like lots of it is enabling the 1891 architecture. So this, and then there's a particular, so how I did it to build it, because there's a complicated process to set up the SD card, is to create my own makefile and do a lot of the setup for copying. For example, the grid.rdf is the FPGA image, and the bootloader is boot.bin, and then we also install all the modules in the kernel when we compile it to set up the NFS directory. Okay, so one interesting thing is that these settings are not, it has an impact, right? So I was playing around with slob and slob. I don't know, they sound exactly the same to me. And I was using slob, but for some reason with the production machine, some kind of race condition that's been known before, if you go to the user forum, came up when we were testing. So what I did is just disable and go back to slob. So it's really important, I think, to keep track of what changes you're making to your configuration file, because you can really get into areas of the kernel that haven't been maybe as well tested, particularly in combination with your platform. So it's really important to be able to do that tracking. So I use the make file to build the kernel. So under it does most of the same tasks that we see when we build a regular kernel, but it's also copying all the file to an NFS directory that I can use for testing. So I export this, and so this has made it a lot easier, because since creating the SD card is very slow, you want a mean to be able to test changes to your operating system. So if you change the init system or you add a service or things like that, you don't want to have to rewrite the SD card. So what we do is we put everything on NFS, and we use NFS boot on the kernel side to use that OS image. And so the other part is, so since you would be using that in different networking environment, you want to be able to find that NFS export. And so for that, I've started using Avaí, so zero-conf, bonjour, publishing of services to find these and look them up, and then execute the kernel against that NFS mount. So this is what the kexec, so I have a script. So when I boot the default SD card and I want to try to test a new image or a new kernel, then I look up the NFS location, and I use kexec on the kernel to boot that particular system. So the parameters in this case, so you see 128 gets its IP by DHCP, and I'm using what I consider a really great systemd, especially for embedded system, and all the NFS root parameters. The other thing I'm doing is that actually that directory that I'm exporting as NFS is all under Git control, so that I'm able to track the changes and make experimental changes in terms of what services or what software I want to put on. So this is just an extract of what the history, the log history for this particular system. So obviously at some point I'm going to need to go back and package an image that can be installable from the ground up. But for development purposes, being able to use Git and revert changes to application that have been installed is really, really useful. So to create the actual the micro SD card, because on this system, everything boots from a tiny little micro SD card. So both the bootloader, the operating system, and the swap is on this micro SD. And so it can get a little bit complicated to get it set up properly with the proper partitioning and all this necessary software. So I've written this script that you can find on GitHub again. So everything else is on GitHub to create this partition of the system. And one key problem I face, it seems impossible to create from Linux, and I don't know why. I've spent many hours trying different combination to come up with because the first partition needs to be a DOS partition, because the CPU will load the bootloader program from that DOS partition. And what's interesting is that it only works if the partition has been formatted on a Windows system. If I try to format it on a Linux system, it just doesn't see it. So there's probably a bug of some kind in the firmware. But because of that, I've had actually to clone partitions to make it work. So there's the cloning option here to do it from an image of a working micro SD card.
Did you also set the bootable flag on the partition as well?
Yes, I've tried so many different options, and it's just like I couldn't get it to work. And I think I started investigating what the differences were at the file system level, but I couldn't figure out like what made it different, really.
You're probably right, it's probably a bug. What you've created is valid, it's just the firmware doesn't handle it.
Exactly. So either I need to talk to Atmel, or, because it's ridiculous, right? I needed to go just for that, to go to a Windows system just to format that partition. So it's kind of sad that they never tested from a Linux formatted partition. So the next step is, so obviously, so now you've got the Linux kernel booting, you've got your basic operating system. Now you want to interact with your FPGA, right? So you've got like this piece of hardware that's memory mapped but you want to expose that so that your user can write to the I/O. And because it's an FPGA, it's going to be very dynamic, right? So that's the difference here. Is the hardware could actually be changing under you. The memory location and what does what is not fixed. So we needed to find a way, or to find an approach to support that. And so we tried to go to something more generic. So we're using an higher performance. So we're using a kernel driver that exposes a memory map interface. So simply take the memory from the hardware device and expose it in user space directly, so that you can just write to it as you will at any other memory location. So you get a pointer, and at different offset inside that memory, you're actually accessing different function in the FPGA. So in addition to that, so we've got use debug it fast to create a file system hierarchy, so you can actually do some debugging in the command line. So this is what it looks like. I don't actually understand what's going on here, but I did because so I had to search a lot to actually do the remap from the hardware memory to the user space. And if people can explain to me everything that's going on here, I'd appreciate it. But it's working, so I'm happy. And this is the function we're calling, so just for reference. So once we've done that, then there's also the aspect of the Lofilo management console. So we built this based on Node.js. So Node.js is either people like really dislike it, or people really like it. I think it's one of these things. But for our purposes, since we wanted something JavaScript, both on the client and the server and the control, to make it easier potentially for user to use, that's what we went for. And we're using a framework called a socket stream that creates web application, makes it easier to create web application. So we start that application on the server, and it exposes internally. Socket stream works with the RPCs. So we've got a bunch of so in the dictionary, name RPCs that you can call from the client side, which is in your browser, right? And you can get that information and control the system remotely through the network. And of course, so once we get the Lofilo management console, once we've made it, we need to run it. And so what I found really great is systemd services. So it makes it really easy to create a relatively complex configuration file and run it consistently. And systemd has great features such as being able to get logs from individual processes and track all the process being spawned under one particular service. And also the other fun feature for an embedded system is the ability to collect boot chart. So this can be done in other ways, of course, but in systemd this functionality is built in. And this is really useful because when you build an embedded system, you want the fastest boot possible, right? Because you might be building a system that's going to be in a situation where there's going to be a lot of rebooting going on and off, unreliable power supply. So this shows you, so the kernel takes 8 seconds, so that's pretty fixed. And then you can dig into the different user space services, and so that was our starting point. And then by digging through the services, we can get, removing some of the unneeded services, we could get the time down to 18 seconds. So that was great win. So it lets you control that amount of time. So I think we could do a lot better, obviously, but I think that's a great tool to get started. And so at some point, so socket stream was nice, so I had the RPCs and things like that. But that meant I needed to write this RPC exposing code, right, on the server side. And that kind of became annoying when I started wanting to test a lot of the services inside the hardware. So at that point, what I've done is to use the D node, which is actually the ability to expose, okay, 10 minutes, to expose some of the functionality as objects, and being able to make calls from the client to the server, but also server calling back to the client. So it's been quite useful because I've been able to do, so this is I'm going to skip the testing slide. So this is on YouTube. If you look for testing LoFilo, I explain how I've tested the unit at the software level. And so I'm able to load, for example, the LoFilo object, which exposes the hardware, and bring that object locally and start making calls to it as if I had instantiated the object locally. And so this lets me do things like there's 4 onboard RGB LEDs, and I want to write values to them, so I could use the LoFilo and just write the values from the client side, and this would automatically be reflected on the server side and also to the hardware. And so underlying all of this is LoFilo.js, so you can find it again on GitHub. So basically the idea is to get from the kernel kind of a registry of all the memory locations that are accessible and create an index of that. And this means so I create this registry, and I have this model, this JSON model of the hardware. So where all the different memory locations of the registers are, and what they do, and in addition to that, I can add constants to the system. So this is just an extract of the full JSON representation of the hardware. So this is very useful because JSON is basically the language of the web right now, so of JavaScript, right? So you can take that object and really easily parse it and use it, both on the server side in Node.js and the client side. And so this is what the LoFilo instantiation looks like. And yeah, so learning more. So this is the updated recipe. Okay, so I've talked about lots of things, but basically, you know, it's actually a lot of work, and I think we're definitely not finished on this platform. But yeah, so you need to be ready if you're building a hardware platform to spend lots and lots of time building it and doing the software. And it's just been a great experience. I've been very lucky to work with great people. And so this is the status. And so we have a small batch that we produce. So we're not selling right now. We're not, and the development is on hold because we're looking for funding. So after a year of doing development from our own, you know, pockets, now I've gone back to consulting to make some money. So this is the status of the project. And there's obviously lots of things we could do for this project to take it forward. And yeah, so this is, if you're interested, you can talk to me. And thank you to Xiu Li. So this is the hardware engineer I was talking about that I met in Shanghai. So really top class, and he's gone to pursue a doctorate in University of Michigan. And these are the guys that were testing from Metroid that were testing the actual board. After I blew up the first one, they came to the factory and helped test the hardware. So I'm very thankful to them, me and my wife. And thank you. This is it.
Any questions?
I sort of presume that you speak Chinese.
No, I don't.
No?
No.
Your wife?
Yeah, my wife does.
Does it
That's
help?
why she was in charge of all the shopping, actually.
I was just wondering if you are planning to create some hardware in China, if it helps if you speak Chinese or have someone who speaks Chinese.
Yeah, I mean, it's as easy as finding a Chinese wife, right? So I don't really. No, but I think it's possible I think it's possible to do business in China without maybe knowing Chinese that much. I mean, I think you should learn it if you're there, of course. But you definitely need a partner. You need a very strong partnership, and that's what's always difficult to find in a startup, right? You need a partner that you're going to be, as strong as, that you're going to be able to live with for a long time and work very closely with. So that's what's key here, I think. And I think it's really, there's some benefits actually of being an expat in China. There's some positive and negative prejudice. So you just need to focus on the positive and have a partner being able to back you up for the rest.
I was just going to say, Ricky, I really liked your video of the production line there. And as a software engineer, embedded software engineer graduate, I was really lucky to spend a week working on a production line in Ireland, doing network hardware and stuff. Yep. And it was one of the best experiences of my life.
Absolutely.
And I'm just thinking, as software people or even hardware people, are there opportunities for us to actually go and see production lines and actually see things like that happening? Because it's amazing to watch those machines. And do they ever open the factories and let people go in and see them and see things happening? Or
I think if you were taking the role of potential customers and you wanted to go and visit the factory, I think it could be arranged. I think they would be open to that. And I think that's probably something we need to organize with the hackerspace locally when we have a lot of foreign visitors, is to go visit these factories and see the actual process of building. So that's, something we'll do in the future.
Can we expect to see you on Kickstarter or something?
The thing is, looking at the cost of the platform, so from what we've done in the competition, actually the hardware competition is very, very intense, right? I think we've got a great platform in terms of quality, and some of the concepts are really interesting, but it's very difficult to be successful in the hardware business. I think you need very strong backing to do it. And Kickstarter for this project is harder because the price point is much higher. So it's much more difficult to get that critical mass that you would get. So it's not like a no-brainer purchase, like, okay, a $10, $20, Kickstarter, where you'll say like, okay, why not? This one is $200, $300, $400 US for one device. So it's something that, it's much harder to get into. So we've talked about Kickstarter, but I think what we need is really a big electronics manufacturer willing to take that forward.
What's the status of the funding? Are you looking for funding locally in China, or are you looking for US funding?
There's no funding in China. Okay, yeah. So the VC, is very underdeveloped. So if you wanted to make money, you need to look at, the best place is California, right? That's where you find the actual money. Now the question is you need to make it into a business pitch, and you need to convince people that this is going to be the next big thing, right? And that probably means bring the price, building enough quantity that you can bring the price below 100, so that everyone can have one. So that's a lot of money, because we're talking about 100,000 units or something, and is there a market for 100,000 units, right? So that's the other question.
So that really touches on the point I wanted to get to. Given the price point and the level of capability that you've built into this, what do you see as the application?
Right. So, I think there's a lot of potential for on the robotics side. I think we're going to see in the very close future, a really emergence of robots everywhere, and these robots are going to be internet connected. So I think that kind of platform is interesting for that, because then you're combining, the Linux operating system, very powerful, and with doing a lot of the sensors and control in the hardware. And key to that is going to be to make it very easy to do FPGA development. And that's difficult right now, because the two major players, Altera and Xilinx, are actually stupid about their development tool. They make it very restricted. The free version only compiles on one core. It's really totally crazy. It's like they don't want anyone to get into FPGA development. And I think one of the solutions to that is actually taking the compile chain and putting it in the cloud. So isolate that stupidity under a web API and let people just focus on their Verilog code or their VHDL code on their side inside their very extensive framework so that they can compile and create the images easily, send them to the cloud, get the image, binary image back, and upload it to the FPGA on the hardware. So that's like the big, I think the big opportunity here is this like very dynamic hardware that we can see. It's very powerful. Other questions?
Yeah? Okay, I think we'll just stop it here. Thanks.
Thank you.
On behalf of Linux Australia.
Thank you. So they just got beaten by Beijing in terms of subway length, but yes. And it started, but they started building it in '95. Okay? In '95 they had no subway system. And now they have one of the second biggest, and probably they're going to go get back first soon in the world. It's completely astonishing. And world busiest port, lots of container traffic. So people often talk about Shenzhen in terms of manufacturing, but actually Shanghai has a lot of factories in the surrounding Jiangsu, and they ship a lot of container traffic. So really good. Now there's some downsides to being in China. So typically, there's two big things that annoys concept that we brought on the platform, and also learning a little bit about how to actually get the platform manufactured in China. So people ask me why, so I'm French-Canadian, I'm originally from Montreal, and people ask me why China? Why are you in China? So I think it's because China is moving, it's booming, it's lots of things happening in China, and obviously with such a large population both in the country and in the city of Shanghai, like, as you know, there's lots of interesting people that you can meet and do project with. So Shanghai is astonishing as a city, so if you've never visited it, you should check it out. Expats living in China, so that's air quality, which has been particularly bad in the last 2 months. And what I found really interesting is to find the equivalent air quality index standard for Australia is 25. And they like, there's these pages saying, oh, if it increases by 10%, it's going to increase death and it's going to be terrible. But actually, you know, we're living in cities that have much terrible air quality. So something that they'll need to fix soon. The second part that's really annoying to expat is censorship. So we don't get the internet that other people get. So we live in a kind of intranet. And I mean, some of the things are expected, social networks, but other. So we have Ricky NG Adam, who is going to talk to us about a hardware startup architecture in China. And I'm going to let him tell himself. Yep. So, as I said, my name is Ricky. This is actually my wife is in the audience. She's also been part of the project. And the project is called the Philo. And if you've read the abstract, I said that I was going to talk about ARM and FPGA, and talk also about a little bit about the China, doing business in China, doing a startup in China. So why should you care about this talk? So I'm going to, if you've never built an ARM platform, then this could be interesting. Some hints on how to proceed, and new ideas on embedded system. So I think we have some interest. Other things such as Blogspot and GitHub, which was blocked for a day, are really, really annoying for developers, right? So you try, as a software engineer, myself, it makes it really difficult to do research, because then you have to get the VPN on, the VPN doesn't work out the time, it's slower, so it's like very, very annoying. But that's the reality of it. Now there's upside. One of the biggest upside, Taobao. Taobao is this huge market that has many different companies selling on. So it's kind of Amazon, but it's actually individual stores that are selling parts. So you can find anything on Taobao. So typically when people ask us, say, could you find this? We say, yes, it's on Taobao. We don't even